Hey buddies, welcome into our final part of the grade 12 probability series. In this video, we're going to be talking about the complementary rule, also known as the NOT rule. Now, basically what the NOT rule is, or the complementary rule, it basically means that the questions that you're going to be doing here, in order for you to answer what the question is asking you, you're going to be using the complementary of what the question is asking you. Now, the idea of this is for you to catch the questions, how they're asking, how are they asking the questions, and for you to understand what is it that you're supposed to do when you do that. All right, so without wasting any further time, let's go ahead and read the instruction here. Now, a random 5-digit password is generated using the digits from 1 to 5. Okay, so now here we have a 5-digit password, which is basically generated. So now here, the first thing that I always need to do is to understand the options that we have here. So I have 5 options here between 1 to 5, right? Okay. So now let me go and read the first question. So the first question says that if the digits may not be repeated, what is the probability that 1 and 2 will not appear together, right? Which is next to each other in the password. All right. Now, when you look into this scenario on this question here, you'll notice that you can't tell for sure how many ways to actually get that, right? Now, what we are going to do here is we're going to ask what is the complementary rule of this, right? So the statement here, it says 1 and 2 will not appear together, right? Then now, what is the complement of that? So the complement of that is what we're going to be using to answer that question. So now the first thing is to look at the complement of that, right? So the complement is basically the opposite, right? So if the question is asking us to find a probability that they won't be appear together, then we need to basically ask what will happen if they do appear together, right? So our complement is when 1 and 2 are together. So this is basically what we're going to use to answer our question. Now, how are we going to be doing this? Now, if we're having this is basically what we call groups, right? If you remember, when we talk about groups, it means now here we'll be able to do the groups. So let's go ahead and answer this question. So when we're doing the group again, remember, we first need to look at the group. So here in this group, we have 2 options. So the arrangement for this group will then be 2 factorial. So the arrangement E and T will then be 2 factorial, right? And then after doing the groups, we need to consider other digits as group, right? So we're going to make other digits as groups, make other digits groups. Okay, so by doing that, then this means now here we have 1 and 2 together, right? And then we have 3 digits that were left. So now if I'm looking at that, then it means I know that I have, if I'm listing here, let me just list there at the top. If I'm listing 1, 2, 3, 4, 5, right? I have these two as a group, 1 and 2 as a group, but then now these ones now they become their own group, right? So now I have considered the group, the first one, the ones that I need to be together, calculated that, then I'll make all other digits, right? Or all digits, make all digits groups. So it means now when I'm counting the groups, including this one that is grouped here, I'll have 4 groups, right? So by doing that now, this means now the arrangement for that, arrangement for this will then be 4 factorial, right? And then from there, I'll find the total arrangement, right? The total arrangement. Now the total arrangement will then be 2 factorial multiplied by 4 factorial, right? Then now I need to find what is the probability of this. Now therefore, probability, it is event over outcome, right? Now the event here, it is 2 factorial times 4 factorial. Now the outcome is if I just arrange these numbers with no restriction, right? Remember, I must not repeat them. So if I'm arranging 5 digits in a 5-digit password, then that means this is going to be 5 factorial, right? This is going to be 5 factorial. And then I'm going to press this into a calculator. So if I'm going to my calculator, I'll have 2 factorial multiplied by 4 factorial, divide this by 5 factorial, and then that will be my answer. So this is the probability that I get when what? When these two digits are together. Now the question didn't ask that though. The question asked what will be the probability if they're not together. Now to answer that, then all we have to do is, when I say the probability when they're together, right, we're going to add those probability. We know that probability together plus the probability not together, it will always be equals to 1, right? It will always be equals to 1. Therefore, to get the probability when they're not together, all we have to do is to take 1 and subtract the probability where they are together. Now you see, now it becomes very easy. So now when we substitute here, we'll just substitute our 2 over 5, and then our answer will be 3 over 5. So this is going to be the answer that we get into number 1. So let's go ahead now and look into the second one. You see how easy this one was? Now let's go ahead and look into the second part. Now let's consider the second question now. So the second question, which is question B, it says if digits may be repeated, what is the probability that the password will contain at least an odd digit, right? So again, if digits may repeat it, let me just underline that. If digits may be repeated, what is the probability that the password will contain at least one odd digit? All right, so now here, first thing that I need to do right here is to just go into my outcome, because I noticed that in the first question I didn't cover that part. So the outcome here is that if I'm repeating my digits, so 1 2 3 4 5, then this will be 5 multiplied by 5 multiplied by 5 multiplied by 5 multiplied by 5. And then this will be 5 to the power 5. Okay, now let's go ahead and look into what the question is asking then. So the question is asking us something that is impossible here. It's asking us to find a probability that a code or a password will contain at least one odd digit, right? Now, an odd digit, it basically means that this code, it must contain, right, an odd number in it, right, or an odd digit, right? Now, this is not possible because right now the minimum here must be 1, so it could be 1 or more, right? But then now, if we look at the complement of this, if we look at the complement or the opposite of this, the complement, which will be very easy, complement will be when we have no odd number, no odd digit. Now this becomes easy right now because we can calculate the probability of that, right? How can we basically do that? All we have to do is we can look at our list. If you remember, our list was 1 2 3 4 5, right? And then from there we can generate a code that doesn't have odd digits here. So now the numbers that are not odd here, it is 2 and 4, right? So if I want to do the arrangement of this now, therefore the arrangement of the ones that are not odd digits, it will be 1 2 3 4 5. So it means here I have two options, 2 and 4, right? So I have 2 2 2 2 and 2. Okay, so now from this, notice that here I get 2 to the power 5. Now do you see how easy this is? Now the opposite, the one that we actually questioned, it was not going to be easy for us to get it, right? So this is basically what this is all about. So let's go ahead and then now calculate the probability of this. So the probability of this is now easily a 2 to the power 5 over 5 to the power 5. Then now going to our calculator, we'll get 2 to the power 5 over 5 to the power 5. Then we're going to get that 32 over 3125. So 32 over 3125. Therefore now, if we want to get the probability that has at least one odd digit. All we have to do now is say 1 minus the one that we just got here. Remember, this was the probability when there is no odd digit. No odd digit. So I'm just going to write no odd because I don't have space. So it means now here I'll just subtract this to that. 3125. And then my answer will be the probability. Alright, 1 minus 32 over 3125. Let me see what we get. Here we get 3093 over 3125.